And we are live. Welcome to another Loki community call. I am here with my awesome host with the most. I'm doing
Hi.
the pointy mic. There we
You
go.
didn't even introduce yourself.
Well, sorry.
He
My name
he
is
is
my
Jay
name is.
Clifford.
I know. Sorry, I feel I should say it. My name is Jay Clifford, and I'm a developer advocate on the Loki team. Nice to meet you all. And this is my colleague Nicole. Nicole, would you like to introduce yourself?
Hi, I'm Nicole van der Hoeven. I'm here to keep Jay in line because clearly he
We should
doesn't
log off
he's
now.
buckling under the pressure. And we've also got, as always, we've got Julie over there. Hi, Julie.
I am the technical writer that is working on updating the Loki docs and other direction.
Oh, yeah, the mirroring thing, right? Today
Hi,
we're pretty
everyone.
lucky because we've got Poyzan Taneli.
Yeah, hi everyone. I'm an engineer on Loki team, and it's great to be here. Everybody should know Jay by now, by the way.
Yeah.
Yes, I think so too.
I
So go on,
guess we
Jay.
could start by saying Happy New Year to everyone, because this is obviously our first community call of the new year, which is pretty wild to think. And I actually think we've started with a pretty cool one for the start of January, or at least thinking about how the community goes. Like, this is where most of the train of conversations go in the community. So I think, yeah, just to sort of take everyone through the topic, is how to run Loki at scale on Kubernetes. But I thought before we get to that, Nicole, I think we had some cool news and stuff that we wanted to announce about GrafanaCon. So do you want to let everyone know about that?
Yes, GrafanaCon is coming. It is a community-focused Grafana organized conference. It was one of the coolest conferences that I went to last year. If you're at all interested in any of the open source projects that is in the Grafana Labs umbrella, you should really be going to this one. There is a CFP that is out right now. If you'd like to talk at GrafanaCon, this is one of the best conferences to go to, even as a first time speaker, because we specifically try to encourage people for that. And there will be help and support if it's your first time. So we are very keen to help first time speakers to get started at this conference. And if you have some cool dashboards of Grafana that you'd like to show off, doesn't have to be professional. It can be just like a cool personal use case. There's also something called the Golden Grot Awards, and the best dashboards are going to win like a trip to GrafanaCon, and it's going to be pretty awesome. So go to that link. This is also in the description below, and maybe we'll see you there.
Absolutely love it. And there's actually been a few Loki community members that I've reached out to put in CFPs for. So if you're on the call and you're listening, make sure you get those CFPs in. I really want to see you there. That'd be awesome. So the call. I think it's really cool that what we're talking about today, because I think it sort of resonates with a lot of people as they're scaling Loki. You know, everyone starts off with monolithic, and then, you know, they're starting to get to a production side. And this is when they start running into problems. So I thought what we could do is sort of talk about setting the stage first, about, you know, why we're even talking about how to scale Loki on Kubernetes. So Poyzan, what sort of problems are we trying to address here? What sort of guidance do we need for scaling Loki? Why can't we just put, like, you know, everything on auto scale?
First of all, I think it's great that we have so many Loki enthusiasts that use Loki at like such different scales. Last 2 times I was in OpsCon, I met with like so many people who do this so good with us. So it's just so motivating to be able to work on this product. And so, great question. What's the trade-off? So if we don't really right-size our clusters in general, like any software, we will either be running into on one end of the spectrum that things are just clunky, they don't work, and you can address why. Or if you go to your point, like scale up everything, give all the resources, things are becoming expensive. So our context here today, how to run Loki at scale at Kubernetes. And we can, I think, safely assume that most of us run Kubernetes on the 3 big cloud providers, AWS, GCP, and Azure. And they all cost differently. So it's not also so easy to say, give me all the resources and take it from there. So we're going to try to cover today what's our best practices in the last 5 years with Loki's professional, cloud offering support. We learn a lot about how to run Loki to the order of petabytes. So we try to share that with you today. But yeah, I think that's
So
generally it.
Poyzan,
Mhm.
I wonder if you could tell everybody, why is it that you're talking about scaling? What have you been doing for the Loki team?
So I've been with Loki, it's amazing, for 20 months now. It's going to be 2 years in April, which it has
Wow,
been the
did you
most
count before the
rewarding.
call?
I know, challenging 2 years of my career. I'm so happy to be here. And since last year, with a couple of colleagues of mine, we started focusing on how can we optimize our footprint and how can we reduce our costs. Because yeah, let's be super honest here. We are all are to make money here at some point. And we looked at each of our components. I don't want to assume, but obviously at our scale, we run distributed modes of Loki for ourselves. And then we noticed a couple of things, that we actually have a number of distinct patterns that we see in Loki at different sizes. We're going to touch on that again. We run 40 clusters nearly at completely different sizes. Some of them are over petabytes of data a month in total volume ingested. Some of them are like fairly small. And in this group, we also have our own dev and testing clusters. And they all show a different like set of needs. And if we run them all the same, either they are under scale or they cost us too much. So we went through this exercise. We kind of looked into how we can automate sizing of our clusters and like right sizing them. We also have from our like some experience borrowed from our great colleagues at Minimise, the metrics database. So this is all coming from that collection of data that we now have a better understanding how Loki behaves at what scale and how much it costs us, and how we can optimize it for our purposes.
We also
And
really love that at Grafana we have a culture of dog fooding. So we use our own stuff. So we use Loki in production. And so when Poyzan is telling us what the total cost of ownership is, and you know how we should size our clusters, it's because that matters to us. You know, it has a very direct impact on us. Before they get to customers, we deal with our own stuff first.
Exactly. And we are basically our all tooling, our own observability system. And we even take it a step further now. We look at our metrics, logs, and traces footprints, like how much we cost to ourselves by experimenting, trying to improve, and developing this software for our purposes. Yeah.
And I guess when we talk about the call today, we're obviously going to take it for granted, like when we talk about all these best practices for scaling, that we're expecting everyone's to follow the rules of Loki and Loki's best practices in some way. So good data governance, such as, you know, I guess, well, like Poyzan, do you want to take us through a few of those sort of like key aspects that they should just keep in mind before we sort of jump onto some of the scaling best practices?
Yeah, of course. I think as we were prepping for this and like kind of getting what should we talk about, I realized there's probably like one takeaway from this entire topic. When things don't work, let's go back to basics and what's like good practice basics for Loki. So Loki is designed for quick, like highly available ingestion that is super light with like minimal indexing, and then brute forcing querying on those logs. So, and it's also designed for people who understand their own infrastructure. So our like labels, the key value pairs that we index around are generally around the organic structure of a cluster. We look clusters, namespaces, and it's quite native to Kubernetes too. We do like, yeah, cluster namespaces, general examples I'm giving of, obviously these do differ for everyone, and your jobs and components, right? So for example, what best practices? We strictly try to restrict our label cardinality to 15 in our clusters, because we know you don't gain much from further. If anything, you lose in both in the write path and the query path performance if you have high cardinality, if you don't really define those labels properly. Or I would admit that Loki's configuration, particularly on the read path, is fairly complex, and Loki offers a lot of knobs. But we have a number of like resources how you can like use this, and yeah, like correct sharding, like defaults that we use for querying, creating indexes, etc. I think those are like one-on-ones to start with, and it's a bit counterintuitive to try to force Loki to do something that is not designed for. Loki will never be able to excel at give me everything you have and look for this particular string in the logs, because it's natural brute forces. We call them like needle in the haystack queries, right? We have optimizations around that, but still, this is not what Loki is designed for at this point. And I think users should always keep that in mind.
So you've been talking about the design trade-offs in Loki and how Loki is very light on the ingest side, but it kind of offloads that complexity and difficulty on the read side, so it's a lot more expensive to query it at scale. So that's something that makes this topic a little complex. And another reason why it could be complex is, people might say like, okay, maybe we need to scale Loki up a little bit, but maybe not to the same scale as we do at Grafana, because we run Loki for our customers, and maybe some other people don't have to put through 2 petabytes a month. So it's also like, where on the spectrum are they? And that's difficult to quantify.
That's true, but I think where we can start is always like, how much logs do you have? How much do you generate? And even if you don't know this on top, like just deploy and see your a day worth of logs and a month worth of logs. And then the next question is like, what do you want from those logs? Is it for you like a reliability, observability type of thing where you look at your logs only when you have a problem? Or is this something sort of like record keeping for you, that you have like transactions and stuff that you regularly analyze over them? Those are like different patterns. But I would say, at least in my imagination and the way I use it, logs are rarely, and please keep in mind that I'm a very operational heavy distributed engineer person doing this on a day-to-day. So for me, they're generally like incident response type of thing. So I don't get to do like, give me 30 days of logs and see. For me, it's about the skill to narrow down in them. So get me a set of labels and then let me find the signal in this noise is the question. Does that answer your question?
Yes, that sounds good. Also, I wanted to ask, like, what are for people who are not sure if maybe their Loki deployment is good enough, or if they should scale up. What are some kind of warning signs to look out for? What starts to happen if Loki is too small?
Okay. I think what I forgot to mention, which can be like different deployment modes we have. And our current offering says that we have the monolithic SSD and the distributed. I think this has been announced before, and I'm sorry to say if this breaks anyone's heart, but we are considering, we made the decision to deprecate the SSD mode, mainly because SSD mode is the simple, simple scalable deployment mode, development mode, that combines a number of Loki components in a subset of them, so reads, writes, and backend. We didn't see many people gaining too much for it. So monolithic, imagine our free cloud offering, right? We say you can get free 50 gigabytes of logs a month. 50 gigabytes is something that most computers can fit right now, right? easily. So that's a good purpose for monolithic. And I think if you need a couple of order of that, yeah, you can put a number of them together. But the moment that you go get close to the order of terabytes, you will need to separate the concerns between your components, and you wouldn't want the ability to be able to scale them up and down independently. That's why we do strongly suggest, like, if you get to the order of terabytes, I think distributed mode will give you the flexibility. And if it sounds too complex and unnecessary, I would always recommend disable everything you don't need. Just like get the basic components. If you don't have any rule usage, disable them. Try to reduce the software to as simple as possible. I think there's a question.
Yeah, so
Yeah,
I
there
think
was. Go on.
you sort of, yeah, you hit the nail on the head there, because I think we have a few SSD users in the room, and I think that it's quite interesting that a lot of them are raising here. It's like, well, they don't want the overhead of using microservices versus, you know, SSD, where a lot of these things are bundled together. And I think we'll kind of like talk about it a little bit, right, as we start talking about how we sort of like, you know, scaling the write and read path. But I found it interesting what you said there, Poyzan. I think like microservices gives you the option of disabling things that you don't need. So that extra overhead, which would always be there in some form if you had SSD, because we're bundling those services as components. And perhaps maybe this is where, you know, a lot of people are scaling back-end services when they don't need to scale back-end services. And I think we'll sort of cover those things a little bit later on. But I guess sort of like moving us, we're talking about microservices a little bit. If we talk about scaling, then I assume no matter what we talk about microservices, we're scaling kind of like the read and write path. And that's kind of like our two focuses for today. And I think sort of talking about, let's talk about sort of ingest first. When we go to customers and when we visit customers and they talk about their data and their logs, and we touched on this a little bit earlier, what sort of the key aspects of ingest are we looking at for our customers? What are the key signs that we're looking for when we start to consider a scaling conversation?
We first ask them, what is the expected volume of logs you have? And it's hard to obviously 100% nail this, but more or less people know. And then the second question we go from there is like, what is the query load you're going to put? And that's nearly impossible to guess. And we're going to come to that next, I believe, because queries are hard to optimize. But again, the first thing to think about querying is like, how many users are going to use your system? And what we mentioned before, like, what is the need that, like, what do you want to get out of from your system? Are these logs for compliance? Like, are they going to sit there until you have an emergency to go through these? Like, and then in that case, your priority is like good retention, right? Make sure that you set it up correctly so that all those log lines are there when you need them. Or like incident management, right? You really need to make the best of the labels that you know immediately where you look at. And I guess like monitoring over your clusters also becomes like even more important then. And then, yeah, more of like record keeping or something that gets close to analytics. It's not something Loki does fantastic at scale, and we talk about that trade-off. But it's still like possible to do at small scales. Our query language is complex, but also gives a lot of functionality. I love that I can generate metrics of logs and stuff. So I guess those are that is the ladder that we think of. The first ingestion volume, and then how many users are going to hit, and then can we educate those users to make the best out of the platform in terms of getting the data back.
So when we're scaling ingesters, I guess our metrics there then is what the amount of logs that they're potentially going to do, and how do we measure it? Is that like on a per day or like on a week, or like what do we expect the customer to come with us so we can start assuming?
Yeah, we generally ask a day, and then we go from there. One caveat there though is when we think about our write path, Note that we said at the beginning, Loki makes logs available immediately because ingesters hold the logs in memory for a certain amount of time, 2 hours in general. And that's a fantastic thing, but also couples our read and write paths. So if you look at the data that is immediately available, queriers, we don't ship the data back to the queriers. Some of the query retrieval logic, for example, like regex matches, happen in the ingesters themselves. And this is this is a trade-off, that like this coupling, sometimes if you have heavy recent load on read load on your clusters, for example, that's actually an additional need on your write path. Those are things that we also like considered. So for all components, I think we're going to come to that. But general rule of thumb is like we look at the P90 memory and CPU utilization. And then we also try to give for the components who need persistent volumes that have like this supports, something like ingesters and like we also try to be incredibly generous there because disks are again generally cheap, and that's not something you want to be bottleneck that and like have an incident where you can't store your logs.
We also have a comment from Carlo here who says, I have a dashboard to check Loki queries, especially catching this needle in a haystack queries. People scanning terabytes of chunks for no apparent reason. Yeah, this is why you're saying that really matters. If that's something that is part of the use case, then you might have different things to consider rather than if there's just one person who does the same query all the time. Like that's a very different use case. We actually have a question that we were talking about with Julie just before the call. So Codecraft Indonesia says, can Promtail export file logging from read log directory?
Julie?
Julie?
You're going to make me say it now.
Yes. You said if it comes up, it came up.
It came up.
This is not really the answer that you're looking for, but we are going to be deprecating Promtail in the next release. And realistically, Promtail, the Loki directory for the Promtail client was forked almost 2 years ago and has been rolled into Grafana Alloy. So our guidance has been go and upgrade to Grafana Alloy, and there's information in the docs. There's a lovely little the Alloy team has really done a great job. They've got a conversion tool to make it easier for you. So basically going forward, we're not going to be updating anything on Promtail, and it's going to be slowly deprecated. So I think your best bet to answer this question is to go and see what Alloy is capable of doing, because all the new features are going to be going into Grafana Alloy, which is our opinionated distribution of the OTel collector, but also has all the Promtail features on top of it. So it's probably not the answer you were looking for, but that's the answer.
But I believe the answer is yes. File logging from read log directory. Yes, Alloy is going to be able to tail log files as well. You should probably switch anyway. They're cooler features. It's a whole pipeline now. There was an office hours about that. Okay, sorry. So yes, Poyzan, we were talking about ingest, and this is one of the reasons why lots of people were using SSD, which is still fine. We haven't really underscored this point, but we are now recommending distributed. And one of the reasons is that with SSD, it's like read path, write path, but there are many components in the read path and many components in the write path, and they don't all have to scale the same way. So two major components on the ingest, on the read, on the write path is ingesters and distributors, but they're not one for one normally. Can you talk a bit about that?
Yeah. So what's the role of distributors, right? Like all logs come in, and distributors' role is to aggregate them in streams and then pass them on to ingesters. So in general, the rule of thumb, what we follow and works most of the time is like you should have half the number of distributors. This is mostly based on experience. So if you have like, X, 2X ingesters, generally X ingesters should do the trick. We can talk about in more detail when we come to the like updated tooling and sizing recommendations. But yeah, that's something seems to work for us. But for on the right pipeline, two vital components, like you said, are distributors and ingesters. And on the read pipeline, I guess index gateways, queriers, and depends on which later you look. And compactor sits in between, which regularly compacts our indexes, is quite vital to the performance of ingesters, because if we don't have available indexes compacted, otherwise all queriers hit all ingesters to look for the data, the log line that they need. One thing I want to acknowledge about SSD, I deeply understand the simplicity need, but really the feedback and like the open issues and everything that we receive, we don't, when it works great, but we didn't see that people gain more about it, like more from it. And one inevitable thing is we support best what we do on a daily basis, and we do improve and learn more and more about a distributed mode because we primarily use it, and that's the motivation. And I think, Nicole, you're on point. Like the most supported thing does change for a product and a company like ours. That's with this growth. So yeah, I do apologize, but I deeply sympathize with it. And yeah, I repeat, like disable everything you can if it doesn't make sense on a distributed mode. Mm-hmm.
So, and I think that's a really cool point as well. And I guess sort of tying up to the ingester point here, I know we sort of chatted about previously before the call, when you look at monitoring your ingesters, is there sort of, are we looking for like, steady CPU utilization in ingesters in terms of their capacity to know that they're healthy and happy? How do we look at like ingesters as we know we've got enough ingesters based upon our ingestion workload?
This week I learned interesting stuff on Right Pipeline, actually, on that stable node. So on an unusual, not too exciting workload, what we see is like quite stable memory and CPU utilization on distributors. They do their job. And I know you asked for ingesters, but I have to come, like my mind works in order. And then what's the bottleneck for in distributors? If we see unexpected CPU spikes in the distributors, that means they have to do a job, and their only job is to validate the log lines that come in. Do they hit limits? There's a detailed doc about this, like what type of limit enforced by which component, distributor or ingester. But basically, that's the first thing I look, like what's wrong in the system that makes distributor do an extra job. And it's the same for any component using. When we come to ingesters, what are the scenarios that we're looking? Ingesters CPU utilization should be fairly low, depending on they're not quite insane unless a user is bashing them with regex matches and like very heavy recent queries. But memory is heavily dependent on the active streams. So if you see an unexpected behavior on memory, do check active streams. Do check if there's an unexpected load, like actual load coming in to your right pipeline. Whereas for CPU, always question first your read pipeline and somebody is doing that. And I think there's a very good question on how to find heavy queries. It's not super straightforward, but for successful queries, we have on query frontends, we have a metrics.go line, and we actually log the query, and it's quite detailed now.
Sorry, let's just read out the question as well from Andre Ziviani. Any tips on where to find where a heavy query is coming from? Grafana dashboard, alert, or ruler? and you're saying metrics.go. We also
Sure.
talked about this with Cyril last time in the last community call. He also shared like a query for it. This is like Loki's meta log, so you can query Loki.
Exactly. And yeah, that I guess that will be the summary of it. Yeah.
Yeah. Here's like I'll post in the chat the query that we got from Cyril
Yeah.
for an example one for how you can query metrics.go.
Mhm.
We also have a comment from Maxim Maximov. We upgraded from SSD to distributed, but there's a deployment mode, simple, scalable, distributed as interim. I have not found clear information how to move to purely distributed deployment mode.
I actually don't know because I haven't heard of this like interim mode. Yeah, I'll have to look for it to be able to answer. Do you guys know?
No, we can definitely have a look to see the conversation there. I feel maybe it's more around the migration guide of basically if you started off with SSD, you know, what's the procedure of moving to microservices? What's, you know, the hang-ups there? I guess sort of like we could probably make a whole nother Loki community call about sort of, you know, transferring between SSD to microservices. So we could definitely.
I wonder if Maxim's using the distributed Helm chart rather than the Loki Helm chart. Because usually when I say
if you could let us know which one you're using.
Yeah. Because the official Loki Helm chart should cover microservices, SSD, and distributed, depending on what deployment mode you put in the chart and how you configure it.
Yeah, and I think it's just like, even if they are using the official one, as I guess for them, it's like if they're already in production with Loki, is making sure that they spin SSD down in the right way and bring up microservices in the right way, so they don't have any sort of data loss or anything in the process. So we can definitely look at having a conversation on that on another call, because I think that'd be really, really interesting.
Cool.
So sort of talking about with like moving across from sort of ingest over to query, we look for, as you sort of said, Poyzan, we look for consistency in our ingesters most of the time, unless someone's doing a crazy query and reaching into the ingesters for that information. So why are ingesters so hard to scale? What is it about ingesters? And kind of bundling that together, sort of, you know, what do we look to cope with this? How do we scale ingesters to deal with some of this trickery in the ingester side?
The thing is, like, the more and more sometimes it looks like in the right sizing is such a problem. There's no like right answer to it. You look on the day-to-day and you feel like, oh, do I need to change these again? But the thing is, it gets very expensive when the balance between like when the load is not really predictable, particularly on like CPU, the overhead you want to give, and also it really depends. If you have a dedicated Kubernetes cluster to yourself, that's different. You can tolerate like your bursts differently, and you can be a noisy neighbor to yourself, and then your resources will be all yours. And you can perfectly like try to allocate the number of nodes you have and further like push your cost optimization around that. But for cases I'm imagining for any company, when you have a Kubernetes cluster, multiple workloads share that, which means multiple workloads do land on same node. And then it becomes tricky to make sure that you allocate the right resources, right requests that you have with a reasonable limit on top, but you don't abuse your usage above your requests. So yeah, I mean, I guess that's the only thing I would think. Particularly complex with ingesters, but I don't know if I'm missing something that you have in mind.
Sorry. Yeah, moving over to the queriers, more on the querier side now. So if we shift over to the ingesters, we've kind of said like ingesters are quite consistent in the terms of how we use them. but when it comes to
Okay,
querying,
that makes more sense because I was
so
like,
sorry,
that,
apologies, that was
they
my
should
bad.
be stable. I'm like, what am I missing? Yeah. But I think that's a great comparison because, so Queriers, right? Query is an interesting thing. Unless you touch it, you don't need it. So we don't perfectly support auto-scaling on Helm now, and I think we can make a promise that we will be investing more in that and like improving how we use auto-scaling internally and providing to our like Helm charts. But basically, queries by nature are heavy on the CPU, depending on what type of query that hit them, and they're quite spiky in their behavior, and it's very hard to right size spiky workloads. And the same thing from the other side, I said about like being noisy neighbors, particularly when you share workloads, it's very, very hard. So what worked best for us is to run as small queries as possible and as many of them, so that first we can, like, there's stateless components anyways, so we try to, in a way, try to treat them a bit ephemerically. Like if we lose some of them, we don't care. So try moving in the further of like cost optimization. What we did was we said we can run them on spot nodes. What are spot nodes? The different cloud providers offer them under different instance types, but basically they spin up faster. So when you configure something like autoscaling on top, you can immediately go from 1x to 5x to 10x if needed. And then, but the thing is, Kubernetes doesn't guarantee as like it's not going to take them away. It's not going to kill your workloads and like reschedule them. So it's more fit for stateless components, so that you don't lose it. But yeah, we can say now on most of our clusters, unless like we need an extra stability for any reason, we run like nearly 80% spot nodes. And then we run quite aggressive auto-scaling patterns. And what do we auto-scale on? On read path, on Queriers, is in-flight requests combined with the queue size. How many requests are queued to be processed. And whereas for other components, looking at the CPU and memory patterns are enough, like how much resource they need, and we add more replicas to the fleet. For in comparison for Querier, because it's very hard to nail the CPU need, and it's always like spiking a lot, how much work we have is a better question for us to optimize around.
And
Does that help?
Okay, so we have a question on the same lines from Erev. Nicole, I hope I'm pronouncing your name right. They're saying you manage tons of clusters. Do you manually right size each of them?
No, there was a time we did. We had to look, like, so we didn't know what to do, and that was exactly what like motivated this project. We were like, okay, this is the cost, but where do we spend the money? And do we really use what we request? And we looked at like cluster, right? And that time we did, okay, let's try to tune them. And one thing that we had like a debate within the team is like the known pets versus kettles arguments when running like large clusters. You want your clusters to be more like kettles, like they are the same, because if they're pets, it's hard to, if they're all individual and different, it's hard to analyze performance across clusters. When you make a change, it's hard to reason about them. And when something is wrong, you really don't know, because that cluster is unique to itself. And in order to not get to that, we like I said, about a year ago, there was a time we looked at this manually. But now we run like scripts that does that for us and look at like long-term patterns. And if we need, I would say we still heavily prefer horizontal scaling, because that's what you benefit most from. And if everything is okay, like if there's no like major organic shift, horizontal scaling should be enough to balance out resource utilization. But periodically, I would say like, yeah, we do need to look at, and now we automate it. Yeah, rolling that out now.
So on that note, then, talking about sort of like horizontal scaling, you talked about sort of queries being sort of ephemeral in nature, the way you sort of treat them. So is it from the query scheduler that you get these metrics from to know how many spot nodes that you need to basically scale out these queries? So we don't, as a practice, vertically scale queries. You should be basically horizontally scaling these out.
Yeah, so we regularly look at the two metrics that I say, in-flight queries and the queue size, and then our scaling is like Keda based. So it's I think one of them decides. Yeah, Keda decides the suggested numbers of the replicas that need it, and then it's up to, and then that makes that decision, but it's up to the Kubernetes scheduler to provide it for you. So it's a fairly complex thing with horizontal pods, auto schedulers, and then Keda, and then our own metrics. We provide them, and then it's still you. That's why it's, for example, that's why I mentioned you need to really be careful about if you're sharing workloads in a cluster. If you don't free reign in your own cluster, because we always have to now be mindful of other workloads in the cluster and let our platform folks know. We can't just say, hey, max our replica to the 10x, 20x what we need, because then there's always a case Keda may suggest something, but then Kubernetes will go, hey, I don't have that many available nodes. So it's more of a multiple nodes moving together, multiple parts coming together type of thing.
Dang, that's really cool. Honestly, I guess that's one of those things you have to negotiate, is like we always see it as like, oh yeah, you just have Loki and that's the only thing that you're running in production in this K8s cluster. But realistically, that's not the case. You obviously have to weigh up everyone else in your K8s cluster.
Particularly if we talk about like at scale, right? Like if you really need in the order of like terabytes, petabytes of logs, and if you need to store them, it's very likely that you have other needs for metrics and other stuff, and this is not happening in isolation. So then it becomes a bit of a like SRE domain expert, DevOps domain expert talk, where you think of them holistically, and then it becomes a bit of platform engineering, I guess, now, the new title.
Poyzan, we have a few questions here, and I definitely still want to get to your Loki sizing guide. So let's just go through this one. It's a little bit long, but I will say it. This is a hard name to pronounce. Yuha Tinsurya. O11. Our users sometimes query logs for very long time periods. There might be multiple months, 30 days at a time, for services which produce logs at about a terabyte per day. How can we auto-scale the queriers so that the queries happen faster and the users don't complain about things being slow? Are there any other ways to increase query performance than scaling more aggressively? I think I would like to say first that there's like one part of this is scaling the infrastructure, but I think before that, you should just look at fine-tuning the queries themselves. The previous community call that we did with Cyril was all about this. So even before you change anything with the infrastructure, that's a good place to start, because he had some really cool ideas for how to change the queries themselves and then how to find those queries. So we spent a whole hour on just that.
Yeah, I think that's definitely on point, because there is a type of usage that you will never be able to satisfy, even if you give all the resources in the world. So start analyzing what's best and if it's really utilized best. And if those people really need like months worth of data for what they do, is the way to go.
Nice. So I feel like this would be like a cool point to sort of unveil your sizing guide, Poyzan. I know we haven't sort of talked around about back-end services and stuff yet, but I think we can sort of like reveal your guide, and then we can basically sort of cover some of those components too. So hopefully we can sort of share your screen on the new and improved sizing page for Loki.
Yes, and under
Sure,
the covers,
sounds great.
I've been poking to make sure it's published
Yeah.
on multiple bridges.
Thank you, all three of you. You've been so patient with me, and I will admit, I'm very sorry, everyone. I merged this PR this morning, and it has been on my plate for a long while. But this is the fruit of the last year, and this whole exercise where we understand our clusters better. I am sorry we took away the tool that existed on this page before, but honestly, it was giving way off numbers that didn't fully make sense, because it was just like multiplying by the assumed ingestion and retention. And one thing you will realize is we're not talking about retention here. Retention will mostly affect your like storage mode. Like if you keep it, and ideally you should, in object store, it will affect your costs, the bill that you pay, and that's what you should look at. But it's not necessarily affecting much about Loki and how it's run, unless you abuse the amount of data by querying, by like, give me the year logs. That's a different deal. But yeah, when it comes to sizing, retention is a completely different thing, and I don't think it affects much how we size our clusters. You will find everything we already talked about here, like a couple of notes. Yes, run as small queries as possible, and then this is the way a blog post by Ed, like optimize query performance. And then if you don't use Loki rules, if you don't need those additional features, don't even scale them up. You don't need the parallel query path. I want to talk about cache, and I'm now thinking we can even have a separate session on cache. It's a whole beast on its own. I will now come to the tool where it talks about like different components and their suggested size for us. I will be improving this doc in the next week or so, adding some in-memory cache recommendations and like some probably like XStore cache recommendations too. And yeah, there's a note about memcache, and I know there's a note about memcache question, I think, in the notes, if I correctly follow. Yeah. If you really don't need the scale, beware, you may not need the memcache, but we're gonna come there. So what are these tabs? Like I said, we were quite with the right sizing exercise we did. One thing we noticed is like we actually have three distinct patterns, three distinct kettles so to speak. And we ended up actually only dividing our clusters into two, like generally mid-size and small ones and really large ones. So we still try to, as much as possible, stay away from the pet thing. But these numbers are only base suggestions, assuming your ingestion load, and don't really think much about the query load, because query load is something as the cluster maintainer is something you will kind of figure out on the way. And these numbers are gathered from a quiet period, assuming like base ingestion around 3 terabytes a day will be like less than 100 terabytes a month. And you will see like the total request, and it gives you, we used to give like total, only the total numbers. And we realize sometimes it confuses people, go like, do I run one node that has like 12 cores and like has 36 gigabytes of memory? No, this suggestion comes from what we like to do. Ingesters, the way we run is zone aware, and we kind of find it nice to have 2 on each zone. So we recommend 6 as small as possible replicas, and that's the logic it goes. And as you go I'm not going to go through each component, but this is, you will find compactor is always a singleton, and it like in general with the load that gets bigger. But you will notice query front and query scheduler, particularly query scheduler, you don't really need more than 2 at all. And like I said, queriers are a thing you need to figure out on your own a little bit. When we go to a mid-size, we see ingestion load getting bigger. Like we need more ingesters and more distributors, but and so as the queriers. But rest of the components are more or less the same. I want to make a pause about index gateways. Here we assume index gateways are the ones that serves indexes that are already compacted, and assuming you use object store, upload it to object store. And they only become a bottleneck if you actually use a massive multi-tenant setup. We are talking in the order of like thousands of tenants, because indexes are compacted per day per tenant, and then you kind of run into this like a lot of files that needs to be downloaded type of problem. That's why these are, I repeat, these are assumed the minimum. Yeah.
Carlo actually had a question on tenancy earlier. Any recommendations about tenancy? I ingest around 6 terabytes a day, so I thought we could maybe use the doc for his scenario. I ingest around 6 terabytes per day, 12 tenants, yet S3 tells me to slow down when Loki writes into S3. I was hoping more tenancy would help me.
I think if S3 is yelling, I would try to increase the allowed ingestion rate to S3. I don't think this is necessarily like something that Loki said, like, can we slow down ingestion? Wouldn't think so. I would look into S3 limits. S3 like does allow bandwidth, but 6 terabytes a day is actually quite small. So I would first look at the provider configs for this one.
And I think it'd be interesting as well to go like back to basics there as well, because we've had in the past where community users have had this issue, and it's come down to less about like the amount of data going through, but the amount of requests going to like S3. So like the amount of like small chunks being like sent to S3. So it could be, I don't know, like the fact that, you know, you have too many labels and they could all be writing small chunks and requesting those in Loki at one time. And I guess like, is there any drawback, Poyzan, from having lots and lots of tenants writing to the same S3 bucket? Could you hit rate limits from having lots of data writing through lots of tenants, or would you never hit like a load like that?
You definitely would, but I would again question if we are on the simplest offering of S3, and that's like related to that. One thing to your point, what one might check is ingesters provide a metric on what's the reason of chunks being flushed and at one point. And ideally, they should be flushed close to full if they're too idle. And like ideally not forced, which means the ingester is shutting down and stuff like that. So that might be another check. But with this much data, because it's small relatively, I would check the S3 offering and like rate limits first. Because that's something we run into at the other end of the spectrum when we push to this. Yes, S3 becomes a bottleneck. And then finally to wrap this up so we can come back to questions is, as you can see, when we get close to a petabyte a month, we do need significant resources, and these are again from quiet times. And if you do like 2-3 petabytes a month, that doesn't necessarily mean these needs to be doubled. It again comes back to Loki being correctly tuned, like labels are correctly used, queries now correctly done. And you may find this is relatively a small number. This is a base suggestion for this type of volume, but at peak time, when multiple users in the order of tens and hundreds try to query data back from Loki, this can easily come near 2000. We do go up to 2000, and then there is a different very interesting like problems that come with the architecture. Now, like all queriers can touch all the ingesters for recent data. So we, for example, push the amount of requests in the network, for example. That's like, those are like different, I think at quite extreme end. And one other suggestion, like quite humbly, I would do is, don't forget, it's like from small end of the spectrum, when moving towards large clusters, there's a heavy maintenance cost that comes with it. And that's why like Grafana Cloud offering now like takes most of it away. And when customers come to us and ask, it's like, what should be my right sizing? We always, this is something that we talked about at the very beginning. We always ask them, it's like, what is your need? And don't forget, as it gets bigger for you, that comes with a serious maintenance cost. You need to understand the software really well now, the trades off, so that you can tune your components and configs correctly. And finally, sorry, just to wrap it up, you would also notice we moved away from kind of suggesting quite certain node types. Any general purpose machine that works for your size, they will come quite standard for 4 cores, 8 cores, 16 cores would do. You should do your own risk analysis. Putting everything on a single node is a failure scenario. It's always an option, but yeah, having a reasonable spread. That's why like X large 4 core, 8 core nodes is generally suggested. But I didn't want to get too prescriptive in this because everyone's setup is different. I know we're on time.
I mean, if you're okay to stay just for a few minutes, Poyzan, I mean, that'd be great. I mean, like for me, it's actually really telling with the fact that you like in your tables that you show that like, oh, we scale up all of these horizontally, but then as you said, you look at like some of our backend components, like the compactor. We like, no matter how big you get, there's always one compactor. We never have more than one replica by the looks of it in the table. So is the reason for that is just we should just be vertically scaling those versus rather than horizontally?
That's the only option, because compactor is a singleton by design. It has to lock the tables. It also does retention and deletes, so it has to lock the tables that it touches, the indexes. That's why it's a singleton by design at the moment.
Very cool. And good. So if someone did have more than one compactor, could that run them into troubles along the line in terms of who's sharing what tables?
I don't know if we have something that prevents increasing replicas. I think we should. But yeah, it's like, so they're going to try to touch the same data, and one of them going to try to lock it. And I'm pretty sure we're going to run, like, you're going to either run into errors or very weird behavior. Ideally errors that prevent you from doing stuff.
This is good to know, because there's a few community issues I was responding to that might be worth a look on that. So I might reach out to them and go, how many compactors do you have running?
I want to answer one question, if that's okay, about the nodes.
Oh, yeah, sure. Which one?
Have the Grafana folks try running Loki on ARM at scale? Yes, as much as because we require quite the scale, as the availability is provided by the cloud providers, we do run on ARM. There is, depending on the size of the cluster, there is significant cost reduction. We can't say like massive performance improvements like ARM, it's claimed, but about up to 10% cost reduction for sure.
We have a few more questions. Maybe we could just rapid fire them for the next couple of minutes. I do want to call out this one. Ecom Ventures posted this in our community post. Would love to go into depth. Okay, we can't go into depth around tuning of the chunks cache. This seems to be the biggest bottleneck on the query side for us. Thoughts?
Yeah, I'm a bit upset we didn't have time to get into cache. So Loki comes with
Okay,
like,
that just means we have to have you back. All
Yeah.
about
yeah,
cache.
I need to work on it a little bit, but I would love
Okay,
to,
okay.
definitely. But basically, in-memory cache will not scale too much because it will become, it depends on the size of the available like memory you have, on the number of replicas you you suggest. It's hard to answer this question because I don't know anything about the scale they talk about. If it's something very small, and that seems to be the bottleneck for them, and I would still go back to basics and look at like, is everything else is performing well at all. If it's like a download and a performance problem, I would go into instance type and question if they're actually using a like general purpose or like a memory. There's no such thing as, I think, memory optimized, but like a general purpose machine that suits their needs. If they close to the end of the large type of, or like mid-size large type of cluster, we do use something called memcached xstore. There's a fantastic blog post about it by her lovely colleague Danny, who implemented that. Xstore basically allows memcache to write data to the attached SSD disks. So we choose like storage optimized NVMe machines, and we just by like 100-fold increase the capacity of our cache. It does come with a lot of overhead because having disks are difficult. Maintaining them is a different beast on its own. But when we move to the order of petabytes, bandwidth limits and like provider object store limits became a problem for us. So that type of massive move to cache really helped a lot.
Okay, so there's a question from David who's asking, I also have a question about multi-tenancy. How can we monitor tenant usage? How many logs are each tenant, or does each tenant push? What about label cardinality? Can we monitor that as well?
So tenant usage, Loki exposes metrics per tenant, how many bytes they ingest. It also exposes how many bytes they query per tenant. They can be used. Label cardinality, you may look at like active streams in general and like what they are, but like to do a label analysis, log CLI is a great tool. There is a very complicated way to get that from metrics.go2, but it wouldn't give like for long term, it wouldn't give like accurate results. I know that query becomes incredibly complex. I've only seen Ed do it at Valve. But yeah, log CLI, analyze labels is the way to go. And I believe there's documentation on that.
Yes, recently updated documentation and a new tutorial that Jay wrote.
Fantastic.
Nice. We also have a few other folks talking about some S3 issues. So S3 slowdown messages as well here. Didn't find a workaround yet. Carlos suggested increasing chunk size to reduce the amount of writes to S3.
Yeah, like Jay suggested, for sure.
Yes.
Do check, why you flush, and do check S3 limits.
And Carla also said, I'd like to size the chunks cache. I don't need X disk memcache though, 6 terabytes a day.
As I said, next week I'll work on that and try to provide like numbers.
We're just giving you homework here.
But
That's what we're doing.
But in general, the kind of intuition is look at how much you have to analyze your query pattern, how much data your users query at peak time a day, and try to kind of go to a percentage of it. But it needs to be like reasonable. It's because if you wanna hold 50%, if they query terabytes of data, and if you want to know half of it, it's very counterintuitive to try to have terabytes of data in memory. So yeah, but try to look at your query path.
Oh, go ahead.
So I'm just adding this to the list. So I'm seeing 2 community calls raised now. So we've got Loki community call memcache, Loki community call monitoring Loki in real time, and we'll just do an entire call about like a prod cluster, and we'll see what you guys do on a day-to-day basis during being on call. I think that sounds great.
Sounds
So
good.
Poyzan, you're back for both of those.
Yeah, that sounds fantastic.
One last question from Yuha, who posted this on our community post as well.
Oh yeah, good
We are
shout.
running Loki in an EKS cluster in 3 availability zones. One of the main cost factors is the cross-AZ traffic caused by the multi-zone architecture. What are the best ways to minimize that cost?
There is no best way to minimize that cost. Cloud providers ask for an arm and a leg for that, and we don't use cross AZ. Like we don't use cross region availability zones either, because it's just very costly. But instead, Loki's defense, like Loki's kind of trade-off for that is like we have multi-zone ingesters. We replicate data 3 times, and yeah, exactly. we are in single AZ because it's like freaking expensive, and it's working absolutely fine. Like as long as you have, like it's a very rare scenario that you use replicas on all zones, and basically unless you have that, you don't lose data. So it's absolutely fine for us.
Andre is suggesting to enable gRPC compression.
Yeah, sure, but I think it has an upper limit. It's like it really depends again how much data you use.
Yeah, I think it's just a trade-off. Like maybe where the cost, if it's that important, or where the lesser availability. I know, like on the mirror side, for every Prometheus we have a Grafana, we have like a meta Prometheus. They always come in HA pairs that are in different zones, and it's pretty paranoid monitoring, but we don't do that for every single component, just for things that are super important. Okay, I think we got through questions, and we're already out of time. Poyzan, thank you so much for joining us here. And I'm sorry, but you kind of volunteered yourself for a couple more community calls.
And it's all live, so we've got it down.
Yeah, and
it's all like it's super fun to be with you guys. So yeah, I'm always up for it.
And people are already liking the docs update that you made. So the sizing guide and stuff.
Cool. Thank you.
Yeah. And then also I want to say again that, if you are interested in anything open source, please consider submitting a CFP to GrafanaCon, because you're the kind of person that we really want to hear from. So check out this link. Is also in the description below. And also, we have a colleague, Usman Ahmad, who's going to be running a different community call, and it's the Grafana Campfire. This one's about Grafana, and you can catch that live tomorrow. You can enable notifications so that you join it when it's live as well. Thank you, everyone, for joining us here, the 3 of you, and also those in the chat who asked the questions. And if you didn't get to your question, or if you have any more, or maybe if you just have some suggestions for future community calls, because we like giving Poyzan homework apparently, then put it in the comments of the YouTube video down below, and we will do our best to do that. We'll just have to find the right people to answer your specific questions. Thanks, everyone. I guess have a good weekend.
Thank you.
Thanks, all. Nailed the outro, Nicole.